have to discuss about transition elements, electrode potential values. Okay, for transition elements, stability of oxidation state, single factor cannot explain. So here we have to take total enthalpy change equal to enthalpy of ionization energy plus enthalpy of hydration energy. H means hydration energy plus enthalpy of atomization. Enthalpy of atomization. So ionization energy individually cannot explain stability of oxidation state. Hydration energy individually cannot explain stability of oxidation state. Atomization also. That means, so when we explain about this stability of oxidation state, we cannot consider single factor. We should consider three factors association. Three factors together value only we have to consider, because different elements, one D block element, one factor more, another factor less. Okay, so that's why, for example, zinc ionization energy more, hydration energy less. For example, vanadium and titanium, hydration energy more, ionization energy less. That's why we cannot explain by one factor for stability of oxidation state. So simply, when we explain stability of oxidation state, we should consider three factors together only. Okay, so these three factors together, we have it del H. This del H related to the electrode potential values. That's why stability of oxidation state, stable of oxidation state explained on the basis of electrode potential values. Electrode potential values. So these electrode potential values, how does measured for transition elements means ionization energy plus hydration enthalpy plus atomization. Okay, generally D block elements electrode potential values more than S block elements electrode potential values. What is the reason? Because D block elements ionization energy and hydration energy values more than S block elements, due to D block elements has small atomic size than S block elements. That's why D block elements more electrode potential values than S block elements. Okay, then if we observe 3D series electrode potential value, scandium to titanium increases, titanium to vanadium, vanadium to chromium, again manganese decreases, then iron, then cobalt little bit, nickel little small amount decreases, again copper more, then zinc is very less. Okay, this is the electrode potential values in 3D series. Here, manganese and zinc compared to observed values very less. Okay, why manganese and zinc values less means manganese off-field stable. This is M2 plus to M. M2 plus to M. Okay, so M2 plus to M. Then zinc is completely filled. So due to off-field stable and completely filled stable, manganese and zinc compared to we expecting values, lower electrode potential values. Okay, while we expecting values, then zinc has more negative value due to, why zinc more negative value means, zinc more negative value due to ionization energy value more, hydration enthalpy less. Due to ionization energy value more, hydration enthalpy less, zinc is more negative. Then already we discussed manganese and zinc compared to expected values very less we get. What is the reason? Off field stable of manganese, completely field stable of zinc. Due to that manganese and zinc less electrode potential values. Right. Among 3D series, copper only, copper 2 plus only, Cu2 plus, M2 plus to M na, M2 plus to M. So copper 2 plus only has positive electrode potential values. Positive electrode potential values. Okay, remaining all are copper 2 plus only has positive electrode potential values. Remaining all elements in 3D series negative. Remain all elements are negative only. All elements are negative values. Only copper has positive electrode potential value. Okay, why copper only has positive electrode potential value? Because, yeah, question, why copper only positive electrode potential values? Okay, due to copper hydration enthalpy. Copper hydration enthalpy not enough for copper converts to copper 2 plus. That means copper converts to copper 2 plus, some energy required. Okay, here transition energy, this is transition energy. So copper hydration enthalpy not enough for, not compensate to here required energy for copper change to copper 2 plus. That's why here copper hydration enthalpy, He, copper hydration enthalpy not compensate to, that means not enough, not to compensate to here transform energy. That means how much energy required copper 2 plus, not compensate to transfer energy from copper to copper 2 plus. That's why copper 2 plus only positive electrode potential element along the 3D series. Okay, now what is the reason? Copper hydration energy does not compensate to the transform energy from copper converts to copper 2 plus. Now already electrochemistry you knows positive electrode potential means, so favor to act as a oxidizing agent. Oxidizing agent or oxidizing power. Negative electrode potential values means, so favor to act as a reducing agent. That's why among 3D series, copper only act as a oxidizing agent. Remaining color properties. Right. D block elements exist or D block elements import different colors due to unpaired electrons present. Due to unpaired electron present, DD transitions takes place. That's why D block elements import different colors. Here D block elements means not completely filled up. That means those elements having D1 to D9. Those D block elements having D1 to D9. That means nothing but transition elements only. Transition elements only import color due to unpaired electrons present in the subshell. Okay. Here transition elements exist or transition elements import different colors due to, what is the reason? Unpaired electrons. Due to unpaired electrons presence. Unpaired electrons presence. Due to unpaired electrons, next coordination chemistry depth come. Due to unpaired electrons present, DD transitions takes place. Due to unpaired electron present, DD transitions takes place. DD transitions takes place. That's why due to DD transitions, D block elements or transition elements import different colors compared to S block elements and B block elements. So D block or transition elements import different colors. What is the reason? Due to unpaired electrons present. So due to unpaired electrons present, they having DD transitions takes place. Okay, this is the reason transition elements or D block elements import different colors. Next, another one. Yeah, important one. D0, D10. D10 means completely filled. D0 means no electron in D subshell. D0, D10 does not import color or does not give color. Does not give color. Next, D1 to D9. D1 to D9 only import color. Import color. This point is important. So D1 to D9 only give color. D0, D10 does not import color. D1 to D9 only DD transition, D to D transitions takes place. DD transitions takes place. DD transitions takes place. Okay. For suppose titanium, what is concentration? 3D to 4s2. Titanium 4 plus 3D 0, no color import. But titanium 3 plus, comma, titanium 2 plus import color. Okay now. For example, vanadium 3D3 4s2. Vanadium 5 plus means 0, no color. Okay, D0. Then vanadium is the reason? Vanadium 2 plus means D3. Vanadium 3 plus means D2. Vanadium 4 plus means D1. So here D3 means 3 unpaired electrons present. 1, 2, 3 unpaired electrons present. D2 means two unpaired electrons present. 1, 2. Here D1 means one unpaired electron present. So due to unpaired electrons present, V2 plus, V3 plus, V4 plus import color. But V5 plus means all d electrons also empty. All d electrons also eliminated. D subshell has empty. That's why V5 plus equal to D0. D0 does not import color. Okay now. Like that. For example, zinc. Zinc configuration 3D10 4s2. That's why zinc also does not import color. Zinc 2 plus. Zinc 2 plus means 3D10. So this is a D10 configuration. D10 means what I say. D10 also does not import color. That's why no color. Simply remember D0, D10 means no color. D1 to D9 import color or gives color. Okay, D0, D10 no color. D1 to D9 gives color. Okay now. Then some elements, for example, permanganate ion Mn4 minus. This is permanganate ion. Permanganate ion. Okay, your manganese oxidation state +7. +7 means D0 ka. D0 because manganese oxidation state 3D5 4s2. +7 means completely these 2 electrons, 5 electrons, 7 electrons eliminated. That's why manganese +7 equal to D0. Then CrO4 2 minus. That means here chromium oxidation state +6. Chromium +6 also D0 because chromium oxidation, chromium electron configuration 3D5 4s1. Here 5 plus 1, 6 electrons eliminated. Here 5, here 1, 6 electrons eliminated. So this is also D0. Although these two compounds import to color. So MnO4 minus, CrO4 2 minus, these two compounds having D0 configuration. Although D0 configuration, these compounds import to color. What is the reason? Charge transfer. Charge transfer. Okay. Here important point. MnO4 minus comma CrO4 2 minus does import to color. Does import to color. Import means giving. Gives. Does import to color. Although having D0 configuration. D0 configuration. What is the reason? Charge transfer. Very important term. Due to charge transfer. Due to charge transfer. Charge transfer. Okay. Here no DD transitions. Here no DD transitions. Although these compounds import to color. What is the reason? Means due to charge transfer. transfer. That's why MnO4 minus and CrO4 2 minus, although having D0 configuration, they give different colors due to charge transfer. Okay, this is see about the colors. So what I ask you, what type of colors coordination chemistry we have to discuss. Next one, the last one, magnetic properties. Magnetic properties. Magnetic properties. Generally, magnetic properties, dia and pair. Dia and para. Dia and para. Diamagnetism due to pairing of the electrons. Due to pairing of the electrons in d subshell. In d subshell. Okay. So diamagnetism due to pairing of the electrons in d subshell. Paramagnetism due to unpaired electrons, single electrons. Unpaired electrons means single electrons. Unpaired electrons present in d subshell. Present in d subshell. So here magnetism two types, dia and para. Diamagnetism due to pairing of the electrons in d subshell. Paramagnetism due to unpaired electrons present in d subshell. Okay. See, D0, D10, D0, D10, diamagnetism. Diamagnetism. Okay, D0, D10, diamagnetism. Because D0 no electrons, D10 completely pairing of the electrons. Next, D1 to D9, D1 to D9 gives paramagnetism. This is completely D0, D10, whatever condition, diamagnetism. D1 to D9 gives paramagnetism. Paramagnetism. So individually, well again when we go to coordination chemistry, depends on ligands. Depends on ligands, magnetism will be changed. Strong ligand means one type of, strong ligand means one type of magnetism. Weak ligand means one type of magnetism coming. But here just to simply discussion, completely filled D10 or D0 gives diamagnetism. D1 to D9 having unpaired electrons, having single electrons gives paramagnetism. Okay, so magnetic moment we have to find out. Magnetic moment nu equal to under root of n into n plus 2 Bohr magneton. Bm means already know physics. Bohr magnetons under root of n into n plus 2. Here n equal to number of unpaired electrons. Number of unpaired electrons. Okay, by using this formula, we have to calculate magnetic moment values. Here n means number of unpaired electrons. That means single electrons present in the orbitals of d subshell. Okay. For example, Cr3 plus. This type of Cr3 plus means what d configuration? How many unpaired electron present? You should learn in last class I given. Cr3 plus means 3d3 because chromium configuration That means from D5 to electron loose means remaining D3, 3D3. Okay? 1, 2, 3. 3 unpaired electrons is there. Now, more magnetic momentum values we have to find out. Nu equal to under root of n into n plus 2. 3 into 3 plus 2. That means 3 into 5. Root 5. So root 15. Root 15 value almost 3.95 or 3.99 like that. For magneton values. Okay. For example, iron 3 plus. Here, iron configuration of 3d6 4s2. 2 electrons from S. Yes, 2 electrons from S. 3 plus na. 3 plus means 3 electrons loose. 2 electrons from S. 1 electron from D. Totally 3 electrons loose. 1 electron loose from D6 means remaining D5. That's why Fe3 plus equal to 3D5. Okay? That means 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay? Now, nu equal to under root of 5 into 5 plus 2. Okay? Root 35. Root 35 means almost 5.95 for magneton values. Okay. Next, for example, cobalt 2 plus. Cobalt 2 plus. Cobalt configuration 3d8 4s2. 2 plus means 2 electrons lost. Remaining d8. d8. Okay, d8 means we write like that. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 6, 7, 8. How many unpaired electrons? 2 unpaired electrons present. 2 unpaired electrons present. That's why nu equal to under root of 2 into 2 plus 2. Root 8. Root 8 means almost 2.94 magneton. Next. Manganese 3 plus. Manganese configuration 3d5 4s2. Manganese 3 plus means 3 electrons loose. From 2 here, from 1 here. Here 2, from here 1. Totally 3 electrons loose. Okay? 1 electron loose from d5, remaining is d4. That's why this is d4. D4 means 1, 2, 3, 4, 5. 1, 2, 3, 4. So nu equal to under root of 4 into 4 plus 2. So root 24. Root 24 means almost 4.9 for magneton. 4.9 for magneton. Next one. For example, nickel 2 plus. Nickel configuration 3d8 4s2. 3d8 4s2. Nickel 2 plus means 2 electrons loose from 4s2. Remaining is d8. 3d8. d8 means we write as 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5, 6, 7, 8. 2 unpaired electron. 2 unpaired electron. That's why nu equal to under root of 2 into 2 plus 2. So 2 point almost 2.9 for magneton values. Next. Manganese 7 plus. Manganese 7 plus means manganese configuration configuration 3d5 4s2. From here to from 5. Total 5 plus 2, 7 electrons loose. 5 plus 2, 7 electrons loose. Manganese 7 plus means D0. D0 means that it should be diamagnetism. Should be diamagnetism. Next, chromium 6 plus. Chromium configuration 3d5 4s1. Here 1 plus 5. Total 6 electrons loose. Total 6 electrons loose. That's why chromium 6 plus equal to 0. This is also dia. Because already I explained D0 means should be diamagnetism. So like that you have to find out again it will come in coordination chemistry. Now we have perfect means coordination chemistry we can easily explain. So everyone D7 for example cobalt 3 plus means what? Cobalt 2 plus means immediately you telling D8. Cobalt 3 plus D7. Nickel 2 plus D8. Manganese 4 plus immediately you tell D3. Okay now. Next manganese 2 plus immediately you tell D5. Iron 2 plus immediately you tell D6. Iron 3 plus equal to D5. Like that you practice, you knowing means further coordination chemistry is in NEET exam also you can easily solve the question. First this configuration you should perfect. Okay, this is about the magnetic properties. Next one, last one. D block elements formation, interstitial compounds. Transition elements formation, interstitial compounds. Interstitial compounds. That means transition elements react with boron, carbon, hydrogen, nitrogen, small atomic size elements. So transition elements react with small atomic size elements boron, carbon, hydrogen and nitrogen to form interstitial compounds. What is the interstitial compounds means? For example, this is any transition element crystal. Okay? Yeah, plus, minus like that. The small atomic size elements trapped in the vacancies. Here one vacancies. Carbon trapped. Then carbon like that. So the small atomic size elements trapped in the vacancies. So trapped in the vacancies of crystal. Trapped in the vacancies of crystals. Okay, so these small atomic size elements trapped means just injecting, trapped in the vacancies of crystals to form interstitial compounds. Example tungsten carbide. Next Fe3 iron carbide and titanium hydride. Simple one. Interstitial compounds means transition elements react with small atomic size elements like boron, carbon, hydrogen and nitrogen to form interstitial compounds. These small atomic size elements trapped in the vacancies of this transition element crystals. Okay, examples tungsten carbide, iron carbide, titanium hydride. This is about the interstitial compounds. Some characteristics of interstitial compounds. different vacancies or interstitial spaces. So trapped in the interstitial spaces like that. Plus minus. For example, this is interstitial space carbon. Plus minus. So interstitial space carbon is trapped. Otherwise plus minus nitrogen. Plus minus. So this small atomic size trapped in the interstitial spaces. Interstitial spaces. Okay, that's why number of cations equal to number of anions become a unequality term, because nitrogen means carbon adding means whether negative ions increases or positive ion increases depend on the small atomic size. Boron adding, nitrogen adding, carbon adding. Okay, that's why when the small atomic size elements dropped in the transition space, interstitial space, okay, so number of cations unequal to the number of anions. Okay, that's why these interstitial compounds are non-stoichiometric compounds. Non-stoichiometric compounds. These are the characteristics of interstitial compounds. Okay. So completed properties of d-block elements or transition elements. Next class we have to go preparation of permanganate ion.